this is the highest point of the site, the highest side of the site here. So what happens is water actually going the other way, sorry, and is still collecting in the back, because this is the area where the building is and the building exists. So actually what we do is here, water will collect in here and maybe in here too. Why? Because this is kind of when water runs off in this direction or runs off in this direction, it will get to the back of the building and will just sit there. And here we are having this area a little bit of a flat area, so maybe water also will collect in here. What we did was exactly what I said before, which is creating a swale. And a swale means what? I'm digging the land here and here and here, exactly what I said before. I'm sorry, I was not disoriented. And the same goes in here. I'm kind of cutting the land. I'm making a cut in the land. So actually when water comes here, instead of going to the back of the building, it will start going like that. So actually I'm making a depression. I'm creating an area. This is still a cut area, as I said before. Cut area, I was just drawing the arrow the wrong way. So the water will start to go around the building. And here, I'm really interested in this area. I will just make it a little bit larger here. In this area, we have this pavilion here, this picnic pavilion pad, which is cement. And as we said last time, it cannot actually be sloped, or it will be uncomfortable for people to sit. So what we said is 1/4 of an inch in every foot. 1/4 of an inch in every foot. Why? To just make water go through. It doesn't collect on the pad. If it is completely flat, water will collect on it. So actually we make like a very slight, you won't even feel it. 1/4 of an inch in every foot. So actually in every, if this is like 8 feet or something, the whole slope between this point and that point is kind of 2 inches. If it is like 8 feet. So actually if it is 8 feet, I will have only a drop of 2 inches for the whole thing. So actually you won't really feel it. But a quarter of an inch is in every foot is actually kind of an average thing you can use. You can do even less than this, 1/8 of something, but it doesn't really make, it doesn't make sure that you lose all the water from collection. Anyway, I'm going to clean a little bit this area here. Clean it. And now we have a new issue that we need to deal with. When we did this, when we did the digging of these side elevation, side grading lines here, let me use another color. When we did this digging, and maybe here also, what happens is we created a swale or an easier path for the water to go around the building. But what we also did was that if this pavilion started from this point here, which I believe was 106 or something, and went through this and went through this, now we're having a sloped soil around our pavilion. What does it mean? It means that we're putting, if I'm drawing a section in this part, if this is our pavilion and the slope is only like 1/4 of an inch for every foot here, and we are putting that on a sloped ground like this, so actually we will have some area here to fill, and maybe nothing here to dig, or I can push it inside. So actually I have a dig and fill area, something like that. But what happens afterwards on the plan between this point and that point is that if I want to connect this very short, very steep slope, it's a steep slope here at this area. So actually I'll find that if this is 106, 105, 104, then I'm having like 2 feet in front as a drop in elevation, 2 feet. And from this point to that point, which makes it very steep. We usually, when we are faced with this, we will clear even this elevation line here. And what we do is we go back to our drawing board and try to move earth around here. So let's extend the 104, because this is now 106. 106 was here, and this is kind of flat. So actually it's almost 106, or like 105, 10 or something, or 105, maybe 9. And this is 104. So there is still a some slope here, like 1 inch and 1 foot and 1/10 of an inch, something like that. I mean, a big drop. So when we move this line a little bit further, it makes this slope here. Draw another line with like this kind of red. So actually, instead of being like sloped like that, and we kind of raise this a little bit, it will be sloped a little bit better. It will be a gentler slope in here. Is this good enough? It depends on the situation. It depends on what's going to happen. And we said something also last time that I would like to remind you of. We said that a mowed, I mean, if you want to have like grass and mow it, it shouldn't be anything more than 33, 34% sloped. What does it mean? It means that in every 3 feet of distance, you have 1 foot of drop. So actually the slope is something like that. Why? Because if you are using a mower, it will be very difficult to move with this mower if you are having more than 1 to 3. It will be very difficult. So we said that the maximum for mowed, for landscape that you can mow is 1 to 3, which is almost 33%, 34%. So what happens afterwards? You plant something or you landscape with something that doesn't need any mowing. It doesn't need to be cut. Is there landscape elements that doesn't need to be cut? Yes. There are many types of actually cactus, and they are kind of spread grass ground cover, but they don't need to be cut. They don't go high. They kind of just spread on the ground to make sure that it protects the ground from moving. I mean, it just stabilizes the ground, stabilizes the earth, so it doesn't move with the rain. So we are having, let me go back to here, like moving like that. Okay, so let me clean it again, and I will try to do this again. Make it maybe summarized. Okay, so we're faced with this situation here where we need to put a pavilion in an area of a park where there is a slope, and the slope is as indicated for this pavilion as they selected the site, is actually moving between 106 and almost 104. So if this point here, let me start drawing again. So if this point here, is kind of 106 and this point is 106, then what happens here is like 105.10 or something, because we cannot actually slope the pad much. And this point still is 104. So there is, if we put the pad like that, from this point, it's all exactly 106 here. And then it moves down like that. So actually in this point here, it's 104. We said that this will make a big slope. Like from here, it will be something like that, sloped. What we need to do, maybe move some more earth to this part, or make it a little bit higher like that. So actually the slope goes gentler and then starts to slope again. Would it help? I don't know. It depends on your design. And we said that to make this acceptable, if you're having grass that you need to cut, you will need to make this slope, the maximum is 1 to 3, which means that if you go like 3 feet in that direction, you drop by 1 foot vertical. So actually every 3 feet, there is a drop of 1 foot and so on. This makes it possible to have cut grass. So if this is more, what happens? Now I'll take you to another solution actually here. Where's that? What's happening? I will go to here. Yes. I will share the screen. There's 21, something called 21 here. Yeah, maybe this. Let me see this. Yeah. Here in this landscape problem, we are having actually an area, and he gives you this issue. It is now 40% along a 30-foot long length between the property line and elevation, which if we walk down here, I mean, it is like, if we only are now drawing, we didn't actually do any calculations, but I'm just showing you this to know that there are calculations behind. So what we have been talking about is that if you connect this point here and that point down there, it's almost like 40%. 40% is more than 1, maybe 1 to 2 and 8 or something, or 210 or something. What does it mean? It means that you cannot cut the grass. You cannot cut the grass. So what you do is you do something like this, which I believe you have seen in many places. You create like some landscape wall here, and the height of the wall depends on your situation. In this case, they selected a 4 feet wall, and they just connected by this point and that point, making each of these slopes less than 1 to 33%. I'm sorry, 33% or 1 to 3. So this becomes like a little bit like 1 to maybe 4, or 1 to 3, 6, or 3, 4 or something. So actually what happens is the slope is less than 33%. And here it is like 27.6. So yeah, this is kind of a solution. But what it entails building a wall here. This wall is not cheap. I mean, this is an additional cost to your project. So when you do that, you can still mow the grass. You can work with a larger slope, but you are creating a wall. When you create this kind of wall, now go back to the original way of our thinking about, okay, so the water actually is coming down like that, and then it will fall down, and then it will continue. This is not, it has to be like calculated and see, so, okay, what will be the impact of this? How would the water, would it fall down, or will it seep on the surface of this wall? What's going to happen in this area? So actually, it's not really an easy thing to deal with, but sometimes this is one of the situations we have to do. And going back to our problem, they kind of, the way we do this is, let me just read again. So actually, what they are telling us is, let me take this off. Yeah. Okay, so what happens is they're giving you options, like you can have this option here of building a 5-foot high retaining wall. We call this wall, which retains land from sloping down or just moving with rain, a retaining wall. So actually, he is giving you options, or that's the options you need, you might want to think about, that you can have this wall like 5 feet high and have it in one place, or 4 feet, or actually there might be another solution. Like if you want, it might be like, let me draw it like with red here. Like if you have this slope, you might have a wall in the middle. So actually you connect the slopes to be something like that. And when you do that, you can actually kind of have a cut grass, but you can do even better. You can have like, you can have 2 walls, one here and one here. So what happens when you have 2 walls? You're having a better slope, and I will draw it in blue, like a slope like that, then a slope like that, and a slope like that. So actually, instead of having 2 slopes of here, they calculated that to be 27.6%. This might be like 20% or something, or even less. We can calculate that too. Anyway, I know that we are not really, I don't want to give you math problems, but I mean, I can, but we don't want to do that now. What I want you to understand is that when we are faced with a situation like the one we have just seen in the problem, like what is the problem is we are having 2 points like here and here, and there's a slope that is more than 33%. What we need, how can we change this into 2 or 3 strips of slopes that we can have cut grass on? I mean, grasses that we can cut. So maybe there is a solution where we have just 1 wall with 2 slopes, each less than 33%. But I have to tell you that even if it is like 27.6, it's not an easy thing to cut, but it is okay. Maybe you don't need that too, because you have like little children walking in the area. So I might want to do something like this, which is like 3, no, let me change the color, green, something like this slope, and then it drops, and then another slope, and then drops, and then another slope. Do they have to be all the same slope? Definitely not. So actually, if I'm really worried about the area just next to the building, I might do this like 1, 2. 10 or something, where children can play and like have fun with this little slope. And then with the two other areas, I can have like 20% or 18% or something. And I can do what, I mean, kind of different varieties of this design here. And the whole thing would be like safe and good for our children to take care of. I mean, to play on. If I have elderly in the building, if I have youth, it depends on who's using your building. So back to what we're talking before, like if I am having this again. Here. If we go back to our
recording in progress.
If we go to our original problem here. Okay, so we are faced with this area to the back of the building here. Let me just put one big color here. This is the back of the building. And this is the front of the building here. So again, I'm gonna do the whole thing, just summarize it. So we are having water coming from that direction because this is the high point of the site to the lowest point of the site. So actually water will like to go in that direction, to go down and lose energy with inertia. So actually it comes here, and then I'm having an issue with water might collect in the front of the building. And I'm having, it might also collect in the back if it is like completely flat or something, but also I'm having a safety issue in the back of the building, because when I am I'm reimagining the grading lines, like with these here, what's happening is I'm creating a swale. A swale is like a lower area, you know, on the site where water can just go through. So actually it instead of going to the building, I'm just stopping that, and I'm attracting the water to go in that direction. And I will do the same on the other side, something like that. And as I'm drawing here, this can be done in different shapes and forms, depending on how much you would like to dig and how much you would like to add soil. So actually cut and fill. The cut and fill at the end should be equal, because you don't want to move earth out of the site or bring earth from outside. You need to make cut and fill almost the same. So actually there, I mean, every line like that, if it is different line, it means a different volume of the cut and fill. It might not go like that. It might go like this. So actually when I'm doing this, I'm doing cut in this area and I'm doing fill in that area. And I can just go ahead and do it all around. Why should I do cut and fill on that? Because I don't want to actually move ground a lot on the site. So actually I'm moving from this area, cut, and I'm filling here. And then I'm moving cut from this area to fill in this area. I hope you are following the lines, because after a while, I'm now moving the earth around the building, and the whole issue is I want to have water not collecting on behind my building, and I need water to go like that in that direction, and I need water to go like that in that direction. I don't want it to collect here, so this will solve the problem. But when I'm dealing with this area behind the building, where because of this picnic pavilion pad, that's almost, we said it's almost kind of level, but at least we have like a quarter of an inch every foot, something makes it like, if I'm starting here with a point of 106 elevation. This point here for the pad will be like maybe 105, 10. 105 feet and 10 inches. Actually sloped a little bit, maybe only 2 inches or something in this whole thing, but we're still having, some slope. So what happens when we have this 105, 10, then the difference between these two lines becomes very steep. I can still play with the grading, like I will extend this new grading line, go like that. So what I did is create a new grading line where I cut in that area and that area, and this area I'm actually filling in the back of the building. When I'm filling in the back of the building, I'm extending the slope. So instead of being like 40% or 30% or something, it becomes like 1 to 20, or 20% or 18% or maybe 8% or 10%. But this might need actually to move earth further. But when I'm doing this, I have to be very careful because this is very expensive. It is costly to move earth on the site because you will need heavy equipment coming to the site, maybe spending a day or two or something like that, maybe more, depends on how much earth you want to move. And then at the end, you are preparing the site for your project. When you do that, look here, do you see the dashed lines here? So actually what happened here is they moved this whole elevation of 105. Do you see that? 105. This line goes like this. And then they change that to here. And then back, 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 and then to 105 again. Let me do it in another color. Let me do it in blue. So actually what happens is I'm taking this line, original line, I'm moving it all the way to here, then back, back, and then here to make the other swale, and then it comes back to 105. So this whole area in blue now is actually cut. And this whole area is kind of fill. A lot of movement, earth movement. And we said that our pavilion is like 105. They actually wrote 105.6 instead of 10. Okay, 105.6. So actually between this point and that point, we have like 6 inches. Might be okay if you want to have like a step of 6 inches. And then between 105 and 104 here, you're having a slope. If this area is like long enough, you have like horizontal movement in that area, long enough to make the slope less than the slope needed to cut the grass. It's okay. If you need, like if you have children and you want to make it safe for them, if you have elderly, if you have like youth, if you want to make it like challenging, if you don't want to use a handrail or use a handrail, this whole thing becomes a design issue. So to conclude on this, when we have a site with topography, and that's maybe the case wherever we go here in Huntsville or in areas like Huntsville, you are always faced with slopes. What we need to do is think about how to deal with this. How much earth do we need to move? Would it be like a lot of cut and fill? Are the cut and fill kind of balanced or not? Do we need like in an area where you will just is very steep, so actually you cannot have a lot of cut, or maybe you went to an area where it is like stone. So actually when you are dealing with stone or a little bit of a mountainous area and you cannot dig much. So this becomes a problem. Now you need to do the handrails, it becomes a must, or you need to do like sloped pedestrian paths and things. If it is like an easy to move earth around your site, around your building, or around the park, or around the pedestrian path, then it might be a good idea to actually move a lot more earth than would you be able to in a mountainous area. Anyway, what we have been discussing during the last 2 weeks is almost all about how to create a pedestrian path. We started actually by drawing something on the AMU campus map, which I already uploaded to the course site. We have talked about the north connection. I believe we had some issues of topography between this northern connection that connects between the old female dorms and the quad and the sport area. And I know that we didn't really tackle much how should we create a good slope for a connection between this northern connection and the quad. We mentioned that twice, or we worked on this twice. But now what we did this week and Thursday of last week was to get specific examples of how to deal with topography. So we can move earth, which we did this time. Last time we were working on only the pedestrian path, like we can move it like that to have a slope of like 1 to 20, and then we enter the site from this area, and then we go back like that. But when I'm actually having to move earth and do the pedestrian path at the same time, I have to make sure that a swale like that doesn't coincide with my pedestrian path. Actually, I cannot build a pedestrian path in a swale or in a very low area like a valley or something, because it gets flooded. So I will do my connection, I will do my pedestrian path on top, or actually on the side of that swale, not in the swale, by the side or in a higher ground. So actually when the water, let me draw the water, if it collects anywhere going down here, oh, this is not really showing. Let me do it in green. If it goes like that, it goes by the pedestrian path to a specific point here where I might need to have like a culvert or a pipe beneath the pedestrian path, or just collect water by the side of my sidewalk to a point where it actually seeps beneath the pedestrian path, or use some material that allows this water to go through without actually damaging my pedestrian path. So when we're dealing with a site and creating a pedestrian path, let's imagine that we're doing that on campus still. I will have to have these ideas. How would I deal with the slope? What happens with like here? Let me draw with that. If I'm having like safety issues, would it be necessary to have like handrails on this side of the sidewalk? And then I'm having like sloped grass areas on the side. What will be the slope where I might need a retaining wall, so on. So actually it becomes like a little bit of a complicated issue of how to deal with slope in a site like this. Are you following?
Yes.
Oh, very good. Okay. Thank you, Mackenzie. So actually what I'm going to ask you to do, knowing that this Thursday might be the last day of our studio classes, depends on what you're going to produce. I would like you to make the same exercise that we have here, which is creating a pedestrian path of, say, let me say 1 to 20 to make sure that we don't need a handrail for the slope of this. And hopefully we don't need that in here, but if we need something up to 1 to 12, then we will need to have like a handrail in this area and maybe a handrail in this area here, but make it very small. And then we need to talk about the back of this building where we are having the pedestrian path go. So how would we deal with the slope here? We need to draw like a section or something, whether we need a handrail or would we play with this slope in the back to make it, if it is like 1 to 12 or something, this will be actually acceptable not to have a handrail. No, I mean 1 to 13, I'm sorry. 1 to 12 is not acceptable because it's ramp, but 1 to 13 is acceptable because it's not ramp. Anything less than 1 to 12 is not actually a ramp. But the best thing is 1 to 20. 1 to 20 is a sloped ground. If we can have like an area here in the back, 1 to 20, this will not need a handrail. It depends on which code you are using. But anyway, in that back area, we might use, as we said before, this like slope and then a retaining wall, and then another slope and then a retaining wall, something like that. So actually it goes into steps. But even when we do that, we are not expecting everybody to be able to jump here. So it's, on the side, there might be some other pedestrian paths here, like, let me draw something here. No, let me draw this. Like here, you might need like some other pedestrian paths, but it's not necessary to show it now. We're not showing this. We're only showing the main pedestrian path. We are showing where we need handrails and we don't need handrails. We want to see whether we can have like retaining walls and make sure that whatever we have is actually in a good slope that we can cut the grass. If we have like younger people, younger children, something, we might need to have like a handrail in here and just limit this area to the use of our children. So actually our children can come only to this area, but not to that area where you don't have a handrail. I mean, things like that. This is all design. If I'm planning on campus, I would love to show, that will be our final exercise for this course here. And I will actually make it only online. I would like you to use the same pedestrian path that we designed before on the northern connection and the connection going down to the quad from that northern side. I think we did this twice. How would you deal with this? What will be the slope? Where would you need handrails? How would you change the grading elevations in the area? Things like that. But I will be happy enough for this Thursday when you come. Please make sure that you all come on Thursday, that we will try to work on this same plan. I would try to kind of maybe print it for you. And what we're gonna do is make sure that we have a good pedestrian path, good slopes and things like that. All right.
All right, sounds good. In Carver, correct?
In Carver 222, yes. Please.
Okay, that's what
But please, all of you come early. Please come early, come on time so that we can have all the time and we'll discuss things. I can see that not all of you are actually completing the assignments. I really don't know why. If you are not attending in person and you are working online, you need to continue with whatever assignments we're having. I'm always posting the assignments online. So Everett, would you like to say something?
I'm still having issues with uploading. Like I can't get it uploaded.
Your voice is too far. But I would like for you to make all the, please do the assignments. I know that some of them like have been a month ago, but I would still accept that if you do it. I need to finalize my grading for the course, and I need to feel that I'm fair to all of you. Some of you were more responsive than others, so actually these students will have higher grades, but I don't know what will be a lowest of the grades, because some of our students in this class actually didn't attend for the last like 5 times, and this will bear heavily on their grade if they ever make it, or I might even give them incomplete. I don't know yet. I will have to talk to the chairman maybe today and see what happens. All right, okay. I think we are done for the day. I will leave this recording, I mean, as usual. So if you want to go back and see it, we are always interested in the area around the building because this is the most difficult. But other than that, we are also interested in the whole of the pedestrian path that comes and goes from crossing the elevation lines. I need for all of you to really see that these lines are virtual, they don't exist on the site. What we're doing, when we change a grading line, we are actually either cutting or filling. We are either cutting or filling. The golden rule is we shouldn't move any earth from the site. I mean, all of our cutting and filling should be kind of equal. The balance. I mean, it will be very expensive. It's in very rare cases do we allow to bring fill soil from outside. Usually we don't allow that, because we should play with whatever we have without the need to bring something from outside. But if it happens, it will be a very rare situation. We need to understand that if the slope is more than 1 to 20, we need handrails for pedestrian path. If it is like 1 to 12, it is allowable, but we need definitely we need the handrail. If it is like 1 to 10, 1 to 8, 1 to 7, this is not allowed at all. It's not really possible to have a pedestrian path of 1 to 8 slope. It won't work. It's against the code, especially the code for the American Disabilities Act, or Americans with Disabilities, and we shouldn't use that. If the slope is 1 to 12, this is the beginning of an acceptable slope, but with a handrail, 1 to 20 is an acceptable slope with no handrail, because now it's not a ramp, it's a sloped surface. We need always to think about where would the water collect, how would we change the water flow around our park, pedestrian path, building. I mean, in a case like what we're having here, I will be very much interested in having, like, let me see, if water is coming from up, then there will be something by the side of the pedestrian path that collects water. So actually it goes like that and then off. And the same will happen here. So actually it goes like that and then off. Inside, if water goes in here, and if water goes in here, there will be like connections beneath the pedestrian path to make it pass, or actually you might allow it to go on top of the pedestrian path, but this is to be calculated. Like, it's not really the best way, because it might take the pavement material with it. So we don't really like that, but if we have to, we'll do it. Many things to think about: safety, ground, surface water runoff, and other things. So see you on Thursday. Expect that we will have something like the same, maybe, or a little bit different for us to work on, maybe only part of the site, I don't know. And let's see what would happen. Anybody having an issue or discussion or something to mention? No?
No.
Okay, please make sure that you look at the assignments. Everything that you can provide for us, please do. All the assignments that were not done before, you might lose grades on that. All the attendance that you didn't do will impact on your grading. So please make sure that you work with the assignments to compensate for your not attending maybe a class or two. Okay, thank you very much. And see you on Thursday, 9:30 sharp.
Okie dokie.
Thank you very much. Have a good day. Bye-bye.